Hello students, welcome to my YouTube channel PhysicswithS.Msir. If you are new to this channel, please subscribe the channel, and if you like the content of the video, please do not forget to press the like button. And this actually gives me more motivation so that I can bring more number of videos for you. So let's start. So in this lecture, I am going to discuss with you what is the application of total internal reflection and critical angle in prism, correct? And here I will discuss with total reflecting prism. Total reflecting prism. And what is the purpose of the prism? A total reflecting prism is actually a 90-degree, 45-degree, 45-degree configuration. That means two sides are equal and it is a right angle, correct? And one interesting thing with this is this, key is also known as right angle isosceles prism. It looks like this. Clear? This angle is 90-degree, this is 45-degree, and this is also 45-degree. How to use this prism and where we can use it, correct? First of all, this prism helps to deviate the light ray by 90 degrees. Number two, this prism can deviate the light through 180 degrees. And number three, it can also produce erect image of inverted object. That means it can able to reverse the image, correct? Reverse the object, image of the object, correct? So let's start the discussion with this. How to deviate it through 90 degrees, correct? Deviation through 90 degrees. Please watch this. In order to draw this kind of diagram, we require a clear concept of total internal reflection and critical angle. If you don't know this, please go through my videos, earlier videos first, and then look at this. So it will help you more, correct? So let me start how to draw this diagram. Look at the technique. First, draw a right angle isosceles prism or total internal reflecting prism. Now, watch this diagram very, very carefully. What I'm doing here, correct? Now, for example, this is A, this is B, and this is C. Each of this angle is 45 degrees. Please mark this angle very carefully because these angles actually required for calculation, correct? Now, if a ray of light falls like this, for example, if a ray of light falls perpendicular to the surface AB, okay, like this. So before going to do anything further, correct, I want to show you something which is very, very important with this. As I told you earlier also, please draw a normal first. That is your basic requirement. And mark this angle. Look, this is 90 degree, this is 45, hence it is 45. And for glass air interface, what we know, for glass air combination, the critical angle is 42 degree. And we know that if the angle of incidence is more than critical angle, so what kind of reflection will take place? The reflection will be a total internal reflection, correct? Now what will happen? Now the path of the light ray we have to draw, reflected or refracted. Now since this angle is 45 degree, which is more than the critical angle for the pair of media, in this case, no light will be refracted. The entire light will be reflected, correct? And TIR will take place, correct? Now look at this. This will be the path of the reflected ray, and then will be reflected outside. Now the question is, why it looks like this? So let me clarify this first. This is 45. So angle of incidence equal to angle of reflection. So this also 45. If this is 45, this angle is also 45 because the total angle is 90. And if it is 45, this is 45, this must be 90. That means ray of light will incident on the surface BC normally. And when it falls normally on the surface BC, that means it is falling around the normal. So no light will bend and it will follow this path and move outside like this. Clear? Now think about this. If I take another point from the just below it or above it, okay, what will happen? Watch this. The diagram will be exactly like this. Now, let me tell you one important thing. First, draw this way, arrow like this. Okay. And now write. Suppose this is P. Suppose this is Q. So now look, the path of P. This is P. And this is Q. Correct? So the image will be like this. That means the image will be like this. Watch it carefully. The image will be like this. That means, say for example, an incidence is occurring at this position, correct? But you are not in front of it. If you are at this position, you can able to identify, you can able to realize what incidence is occurring here, correct? So this is actually used in periscope, correct? So this idea actually used in periscope. Is it clear? So this is used in periscope. Okay. So this is how to deviate the light ray by 90 degree, correct? Now I'm going to show you how to deviate the light ray through 180 degree, correct? Now please watch this. Now I'm going to show you the deviation through 180 degree. Okay, now what I'm doing the same right angle light prism, right angle isosceles prism. Okay. Now watch it. This is 90 degree. And these two angles are 45 each. I told you this earlier also. Please draw the angles because this will require for the calculation. And suppose this is A, this is B, and this is C. A ray of light, for example, falling like this, perpendicular to the face BC. Perpendicular to the face BC. Now look, what will happen? Without further drawing anything, first calculate the angles, correct, which are very important. Draw the arrow, and this angle is 90. This angle is 90 means this angle is also 90. If it is 90, it is also 45. Now your task is to draw a normal on this, correct? So let me draw a normal first. Okay, normal on which face? Normal on the face AB. So this is the normal term. Now let me calculate what is the angle of incidence. Since this angle is 90, this is 45 means this is 45. So what will happen? This is more than the critical angle for the glass air pair, correct? So what will happen? No light will be refracted. The entire light will be reflected. So TIR or total internal reflection will take place, correct? Now let me draw the refracted ray. Reflected ray, sorry. Now watch it. Now the question is why I am drawing this ray parallel to the base. Okay, let me do this calculation again. This is 45. Okay, because angle of incidence is equal to angle of reflection, and this is a normal, so this is also 45. So if it is 45, it is also 45. And if it is 45, now if I draw a normal at this point, so what will happen? This angle will be 45. So watch this triangle and watch this larger triangle. Both the base angles are equal, and this ray will move parallel to the base, correct? Now at this particular face AC, angle of incidence is 45 degree, which is again more than the critical angle for the pair of media. So what will happen? No refraction will take place. The entire of the light ray will get reflected, correct? So how it will move? It will move like this. Yeah. Now, if you watch this very carefully, why this is again normal? This is 45, so this is 45. And these are 90 degree, so this is 45. And obviously, if it is 45, so it is also 90. So if you watch it carefully, the light ray is moving like this. Means if I draw the path of, if I mention the path of the light rays by PQRS, watch it. Incident arrow is going upward, but the emergent arrow is going downward. That means those two lines are anti-parallel. Hence, what will happen? The deviation is 180. Now, let me draw another important thing. Let me draw another identical type of rays, correct? Falling like this, and then it would move like this, and then it will move like this. Okay. So please mark it. Okay. Now, as I told you earlier, please draw the object. Suppose this is the object. Okay. Suppose this is the object. Now, watch it carefully. This ray P, okay, watch this. The image of the point P, if you follow the path of the light ray, is S. And if I consider this as P prime, okay, if I consider this as P prime, so what is the corresponding image This will be S prime. Now, if I join S and S prime, look, image gets inverted. Clear? Image gets inverted, correct? So, where it is used? It is used in binocular. Correct? This is actually how to produce deviation by 180 degree. Now, I am going to show you how to erect an inverted image. Correct? How to erect an inverted image. Clear? Now watch it. With the help of the same right angle triangle, right angle prism, I will do this. Okay. Okay, watch it carefully again. Okay. Now, again, this is A, right angle, this is B, and this C. This is 90 degree. It is 45. It is 45. Okay. Now, look at this diagram. It's a very interesting one. I am taking a light ray which is incidenting on the surface AB like this, means parallel to the base. Now, what will happen? Okay. Before doing anything further, as I told you previously also, you have to complete the normal first, correct? So draw the normal. Now, look. This is what I mean. Is it possible to tell what angle is this? Can you tell me? This is 45. So this is 45. This is 90. So obviously this is 45. Correct or not? Now, when this rays goes inside of it, what will happen? Now, the ray is moving from rarer to denser medium. Correct? Watch this diagram very carefully. It's a very important one. Watch it. This will bend towards the normal. Will it bend towards the normal or away from the normal? Will it bend towards the normal or away from the normal? This is 45. This is 45. Look, this is 45. If I draw a parallel to this, clear? This is 45. If it is 45, this angle is what? Less than what? 45. Correct? Clear? So this angle is less than 45. It is quite clear. Okay, obviously this is less than 45 because look, it is bending towards the normal. Now, the main consideration is what is the value of the angle of incidence in this surface? What is the value of angle of incidence in this surface? Correct. Now draw a normal again. Okay, watch it. This is 45. Okay, this is 45. This angle is 90 degree. Yes or no? This angle is 90 degree. And this angle is less than 45. So what will be the value of this angle? I want to know. That's a very important question. This is 45, this is 90. What will be the value of this entire angle? It is, say for example, anything less than 45. That means anything less than 135 degree. Clear? Anything less than 135 degree. Clear? Now what will happen with this way? What will be the angle here? That's a very important question. You can do this calculation. Now this is 45. This is what? Any angle less than 135. So if it is 135, so 135 plus 45 is what? 130, 180. Clear? But it is less than 180. It is less than 180. Correct? It is not 180. It is obviously less than 180 because it is less than 180 because 180 is this total angle. 180 is this total angle. This is less than 180. So this is the angle. What will be the value of this angle? Is it equal to 45 degree or less than 45 degree? Look, if I take this as 45 degree, just a moment, take this as 45 degree. So 45, 45, this must be 90. But it is more than 90. That means this is less than 45. Correct? So if it is less than 45, so it is quite clear this angle of incidence is more than 45. Clear? This angle of incidence is more than 45. Here, this is more than 45. So what will happen? Angle of incidence is more than 45. That means it is more than critical angle. So TIR will take place. Okay, TIR will take place. Okay, now this will be the path of the light ray. Now, how it is falling on this surface? You have to do the calculation again. It is 45. It is 45. Look at this very carefully. It is 45. It is what? Less than 45. It is less than 45. So what will be the value of this angle? Is it normal? Is it 90 degree? Is it possible? If it is 90 degree, this 45 degree, 135, so this must be 45 degree, but it is less than 45 degree. So it is what angle? It is more than 90. Correct? So draw a normal like this again. It's an angle more than 90, but less than more than 90. Correct? So what will happen? In this case, what will happen? Will this ray will refract it back in the prism or will it go outside? Look at this. Please tell me what will happen. This will move like this. This will move like this. Just a minute. So before going to do any kind of thing, please make the calculation clear. Please make the calculation clear. Correct? Is it clear? The ray will move like this. Now, if I draw an identical diagram, okay, if I draw an identical diagram, if you find, look at this. This angle is what? This angle is what? It is parallel to this 45 degree. 45 degree. Because the angle, this angle and this angle are exactly equal, hence this is 45 degrees. So it is moving parallel to the base again. Now, if I take another ray, watch this carefully. Parallel to the first ray, the ray will go like this. Is it clear? Now, if I draw, let me draw the arrow first. Let me draw the arrow first. Now watch it. If it is P, let me observe the image of P. This is P prime. This is Q. This is Q prime. Now take an object. Take an object. This is suppose PQ. Correct? Now look how it is. That means inverted object now becomes erect. Correct? This is a very, very important application of 180 degree, 90, 45, 45 prism. And this is actually used in slide projector. This is used in slide projector. So this is used in slide projector. And this is also used in some kind of camera, some types of camera. Okay. Now I'm going to show you the action of equilateral prism. Okay. Action of equilateral prism. Take the example of equilateral prism. Okay. So a 60 degree, 60 degree, 60 degree prism. Correct? And equilateral prism is a 60 degree, 60 degree, 60 degree prism. Correct? Now watch this. What will happen? A ray of light, suppose falling normally. Okay. A ray of light is suppose falling normally. This A, this B, this C. This is 90. Now, if the ray of light falls like this, so obviously this is 90, this is 60, so hence it is 30. Okay. Now let's draw a normal first. Let's draw a normal first, correct? Now the question is, if it is 30, so this angle is what? 60. Okay. Now, next part is why it is going like this? We can do this calculation easily. This is 60, so this is 60. This is 60 already known. This is 30, so this must be 90. So this is the action of equilateral prism, correct? And this is the application of DIR in equilateral prism. Now let's draw a 30 degree, 60 degree, 30 degree prism, 90 degree prism, 30, 60, 90 prism. Let's draw a 30, 60, 90 prism, correct? It is in this. Action of 30, 60, 90, 30, 90, 60 degree prism, correct? So 4 different diagrams are given. We have to complete the path of the light first, correct? So let's start from the diagram 1. This diagram 1, this diagram 2, and diagram 3, and diagram 4. So I told you this earlier also. In order to complete this ray diagram, first you require to draw a normal, which is very, very important, correct? Now let's start drawing the normal first. In the first case, this will be perpendicular to this surface. Okay. So if it is normal, it is 90, it is 60, it is what? It is then 30. This will be obviously 60. Clear? So angle of incidence is more than critical angle, correct? So what will happen? The light ray will move. Light ray will show total internal reflection, correct? So now the question is how this light ray will move, correct? Now look at this. This angle is 60 degree. Clear? So this angle is also 60 degree. Clear? So if this angle is 60 degree, so this angle will be what? 30. Correct? Now draw a normal first. Okay. Now what will happen? This angle is 60, this 30, calculate this one, this is normal. So what will be the value of this angle? This is very, very important calculation. This is a normal drawn, so this is 90. This is what? This is 60. So 60, 30, 90, correct? So, okay, let's draw this arrow first. So 60, look at this, this is 60, this is 30, this is 90, 180, this is 30. Okay, now the question is, what is the value of this angle? This you have to do with the help of geometry. Clear? What is the value of this angle? This is 60. So balance angle is what? This is 60. Balance angle is 120. Look, this angle is 120. This is 30. 120 plus 30 is 150. So this will be 30. Less than, that means less than critical angle. So what will happen? In this case, light ray will get refracted. Okay, and it will move out. Please pause the video and try to calculate the angle again. Okay. Okay, I'm showing it for you again. Look at this. This is the line. Watch it. This is the line. Okay, this is the line, and this is the line. This angle is 30. Now, this angle is 60. This angle is 60. And this is a straight angle. This angle is 60. And this is a straight angle, so it is 120. If it is 120, this is 30, this must be what? 120 plus 30 is 150, this is 30. Is it clear? So this is the way of completing the diagram. You need to know the calculation clearly, otherwise you cannot do it abruptly, okay? Now let's do the calculation for this diagram. This is 90. This is what? 60. So draw the normal first. Draw the normal first. This is the normal drawn. What is the value of this angle? Value of this angle is 30. Watch this carefully. If it is 30, okay, so what will happen? Is it more than critical angle or less than critical angle? It is less than critical angle. So light ray will get refracted. And since it is moving from denser to rarer, it will move away from the normal. So this will be the path. Okay, let me draw it by black line. Okay, this will be the path. Is it clear? Okay, next. Look at this diagram. This is falling like this. So extend this line first. Let me extend this line. It is falling like this. Okay. Now our task is to do the normal, draw the normal. Let me draw the normal first. Okay. Now 30. This is 90. 30 plus 90, 120, so it is 60. If it is 60, that means this ray of light is making an angle of 30 degree with the 30 degree with the normal. So what will happen? Will it be reflected or refracted? Obviously, it will be refracted because angle of incidence is less than critical angle. So how it bends? Since it is moving from denser to rarer, it will move away from the base. Correcto? So the diagram is this. Complete diagram is this. So the light ray will move like this. This is the diagram. Okay. Now let me finish this with this diagram. Again, extend this line. Let me extend this line first. Okay. Now draw the normal. Without saying, means before saying anything, do your job first. First, complete the normal drawing process. Now this is 60. This is what? This is 60. This is enter 90. So this is 30. Okay. This is 90. This is 60. So this is 30. If it is 30 degree, so in this case, this angle is 60 degree. If it is 60 degree, sorry, 60 degree. If it is 60 degree, so obviously angle of incidence is more than the critical angle for the pair of media. So in this case, obviously total internal reflection will take place, correct? And the light ray will move like this. Because angle of incidence is equal to angle of reflection. So it is also 60. Now watch this. If it is 60 degree, so this angle is what? 30. Correct? If it is 30, so this angle is what? 60. Now there is, that means what is the angle of incidence now? Draw the normal first. Look at this. If I draw the normal, look at this. This is 60. So this is 30. It is 60. So this is 30 again. So what will happen? In this case, angle of incidence is less than critical angle. So the now the light ray will be refracted in the next medium, correct? And since it is moving from denser to rarer, it will move away from the normal. So the path of the light ray will become like this. Is it clear? So this is all about prisms, application of total internal reflection, critical angle in prisms, etc. So that's all for this chapter. Continue to watch my video. Okay, I'm going to share with you the refraction at curved surface very soon. Correct? Okay, good night.